These wafer washers use ultra-pure water to clean the wafer and then dry it with nitrogen or hot isopropyl alcohol. Cleaning the wafer happens rather frequently in order to remove any stray particles that may have fallen onto the wafer. And finally, sixth are tools that inspect the transistors and metal layers for defects and are called metrology tools. A common metrology tool uses a scanning electron microscope with nanometer-level resolution to take pictures of the top surface of the wafer and determine if there are defects such as improperly patterned layers or particles on the surface. When fabricating an integrated circuit that takes 3 months to complete, it's important to repeatedly monitor the progress and make sure that each of the processes is being executed with nanometer-level precision. Now that we've covered each of the categories, here are the color-coded process steps along with the layout of the tools in the semiconductor fabrication plant. Let's run through the complete set of steps used to manufacture a single metal interconnect layer. First, a layer of insulating silicon dioxide is deposited onto the wafer. Next, photoresist is spread across the surface and the wafer is sent through a soft bake to remove the solvent. The wafer then travels to the photolithography tool, where the design from the photomask is transferred to each of the chips on the wafer by weakening the areas of photoresist hit by the light. The wafer next goes to the developer to wash away the sections that were hit by the light from the lithography tool and then through a hard bake to harden the remaining photoresist. With the mask layer built, the wafer goes to an etching tool, where a plasma etcher removes a vertical column through the exposed silicon dioxide until it reaches the previous layer's metal vias. Next, the wafer is sent to a photoresist stripper, where the mask layer is removed. The wafer then travels to a physical vapor deposition tool, where a sequence of metals fills in the exposed pattern and coats the wafer in metal. Finally, the wafer is sent to a chemical-mechanical planarization tool, where the metal is ground down so that all that remains is a flat layer of insulating silicon dioxide and conductive copper interconnects that match the pattern from the photomask. A single metal layer is now completed, and the wafer is ready for the next cycle to begin, where insulating silicon dioxide and the vias will be added. Note that cleaning and wafer metrology or inspection steps occur in between many of these other steps. Furthermore, the process steps to make the transistors are less straightforward and utilize the ion implanter, and thus we'll cover them in a separate video on transistor physics and design. These steps are for building the integrated circuit on the wafer. However, there are additional steps in manufacturing a microchip, which we'll explore in a little bit. But before we get there, one important thing to note is that the semiconductor industry is incredibly secretive regarding the exact tool layout and the process steps and recipes used to make the transistors. We wanted to make the best